Hi guys, so the first video is going to be on the synthesis of dyes from phenyl amine. Okay, you should know phenyl amine looks like this. Okay, so it's a secondary amine. Right, so it's called synthesis of dyes because the product has a very vivid colour, so it's used to dye your clothes, dye food colourings, pigments, all the things like that. Right, we make it in two steps. So the first step is called the diazotization step. I'm not going to say that again because I'll get it wrong. And you don't have to say it in the exam, you just have to spell it, right? And this reaction, this first step forms, here we go, the diazonium ion. Okay, which is the intermediate. Alright, so the reagents you need, just in case you want to make your own at home, is phenylamine and nitrous acid, available from all good pound shops. Right, so nitrous acid is made in situ, okay, and that means that it's made in the reaction vessel with all the other reactants rather than made before and then added, okay, because it's so unstable. You have to make it just at the same time as the reaction, okay, and right, it's actually nitrous acid, and it's made in situ by adding concentrated HCl and NaNO2, which is sodium nitrate. Okay, so the first step, alright, you need nitrous acid, which you make in situ by reacting HCl and sodium nitrate together. Okay, right, so that reaction will look like HCl plus NaNO2, you get your nitrous acid and sodium chloride. Okay, and this is what you're going to react with your phenylamine. Okay, right, so the equation for making your diazonium ion, okay, you don't need to know the arrow push, you don't need to know the curly arrows, alright, you just need to know the overall reaction. So you've got your phenylamine plus your nitrous acid, which you made in situ, okay, plus HCl, okay, and that gives you, okay, your benzene diazonium chloride. Okay. Okay. Plus water. Okay. Make sure you draw your aromatic ring in the middle. So you've got your benzene, diazonium chloride. Okay. Or you could write it like C6H5 N2 plus Cl minus. Okay, and that's your intermediate, and that's what you get for the first step. Okay, but what I'm forgetting, okay, is this has to be done quite cool, less than 10 degrees. Yeah, less than 10 degrees. Right, that's the first step. Okay, the second step is the coupling step. Yeah. Right. So in this step, the benzene diazonium salt formed in step 1 is coupled with another aromatic compound, e.g. phenol, okay, which is done under alkaline conditions. Yeah. Okay, to form an azo dye, okay, which is what's used in pigments and stuff like that. Okay. Right. So the equation for that so you've got your salt from the first step, okay, and you try to couple it. To your phenol, okay, and it's in alkaline conditions. Okay, it's also going to be done in alkaline solution. So overall, alkaline conditions. Okay, now the main product you want is your azo dye. Like this. Okay, but you also get H2O and sodium chloride as well. Okay, but this here, oh, that's a mess. This here is your azo. Where's that? Just better. This here is your azo dye. And this bit here, this N, the bond N, is your azo group. Okay, right. So the important thing to notice is that in your salt it's an N triple bond, alright, and the positive charge is on the nitrogen nearest the phenol ring. In the product it's double bond. Okay, I don't think you'll get asked, but you could couple it with an amine instead, so it would have an NH3 here instead of the OH. Alright, and all that would change is that in your product this OH here would change and be NH3. So whatever group is on the other side, okay, is just there in the product, and the salt, this N, bonds onto the fourth carbon. So you got 1, 2, 3, 4. You don't even know why that is, but that's at university level. But this OH group or NH3 group is called power directing, which means it directs attacking groups onto this carbon here rather than carbon 2 or carbon 3. But you don't just know that, right? All you should know is that the group opposite, if it's OH, NH3 or whatever they give you in an exam, it will just be there in the product. Okay. So the last thing Okay, just remember those questions they say are suggest a use of, or give a, what could this be used for. So Ada dyes can be used for, you guessed it, or I told you earlier, dyes, food colourings, dye stuffs, okay, and pigments. Okay, right, cool. I hope that was alright. Any questions, ask me, and as you'll see in lesson tomorrow, I'll give you some questions and mark schemes on this. Okay, see how you get on.